Hey guys, so in this video we are going to talk a little bit about TDD and test-driven development. So let's get into it. Now, TDD or test-driven development is a very common practice in software development. If you want to be a professional software developer, you need to be aware of this. Trust me, if you are unaware of what test-driven development is, or what unit testing is. If you don't know that, then trust me, you have not worked in a professional capacity. This is very standard practice in almost every single project that you will ever face at the professional level. However, what I want to touch on in this little video of mine is the different approaches to unit testing that there is and the way that I kind of think about them, and just to kind of go a little bit deeper than just the bare bone like concept of the thing. So, what is a unit test? Well, a unit test is just a piece of software or a test that you write in order to test something else. What does that mean? Well, let's say for the sake of argument that you wanted to implement a function. You want to create a function for a feature that you're working on, and in order for you to make sure that that function is working in a correct manner, you would first write a test. In other words, you would create a test in your test suite. In JavaScript land, that's going to be Mocha, Jest, something like that. There are others, of course, which you can use, but those are probably the more popular ones, at least for just doing Node.js development or anything of that nature. And you would simply write a test first that checks that, all right, if your function is going to add two numbers together, for example, then the test should check that 1 + 1. If you pass 1 and 1 to that function and it should add them together, you should get a 2 back. That's the basics of it. That's all the test is supposed to do. So when you first run it, you don't have an implementation. So the test is going to fail and it's going to tell you that, hey, this function is broken. Then when you verify that your function is broken, you go and implement the logic so that the test passes. That's the theory, or like the mentality that you have, that you write the test first, make it fail, and then you implement the logic. Now, that's the ideology. That's the way that the most zealous and religious defenders of test-driven development, or advocates, let's call them that, want you to work. This is not how the world works. Just like with most ideologies, it's a mix. This, what I just explained to you, this is absolutely there are people who can do this, but it's really uncommon, guys. I don't think I've ever worked with anyone who like 100% rigorously follows this practice. So what I'm going to tell you is the 3 ways that people generally do this sort of testing. This was the first one. Because the 3 ways is usually that they have 100% test coverage and they're like super religious about it, and then you have the pragmatists, and then you have the people who don't do any type of unit testing, and I'll talk about the pros and the cons of each one. So the pros of having this 100% test driven development is that the quality of your software statistically will be higher. If you have 100% test coverage over your entire project, which means that you have tests that tests all of your code, all of it. What happens when you do that is that anytime you change something within whatever you do, whatever you change within your code base, if you broke something, you will be notified immediately. You will immediately know if something broke, because the tests that you write are going to fail. And usually when you write a unit test, you have at least 2 of them per function that you make. You're going to have at least one for the happy path. In other words, you have one test that makes sure that your function is doing the thing that you want it to do. And then you have a failure case where you try to break your function. Like if you say in JavaScript, if you try to add a number and a string together, you should fail that unit test. It should not work. That's basically how it works, right? So that's one path of doing it, like religiously, 100%. You will find this sort of way of working to be extremely rare. The only people who I would argue really does this is the sort of people who has to have everything 100% correctly. And that's going to be blockchain people, and that's going to be NASA or people who work with embedded systems. Like if you have, say, a pacemaker, that software needs to be 100% correct. If your software's correctness is more important than anything else, religious 100% test-driven development is the way to go, in my personal opinion. Then you have the other extreme, which is where you don't do any unit testing. Now, the benefit of this is that if you are in a hurry, you need to get stuff done quickly. It's very, you just write software, and then you manually test it a little bit, and that's great. The benefit of this is that it takes less time, because writing tests takes a lot of time, or it takes longer at least. And that's why especially in object-oriented programming, where you have to stub and mock, and like I have entire videos about just the pain that can be associated with writing a unit test for a really complicated data structure. It can get really messy to do this, so it will take longer time. So it's absolutely a viable option to not write any unit tests. And I will argue that when you don't want to write any unit tests is if you're like starting, you're day one on the project, you're writing some stuff just to see if it's going to work. You're making a prototype or a proof of concept, something like that. You are not so, your project hasn't really stabilized. It hasn't really become something solid yet. It's kind of liquid. You're just trying some stuff out, trying to figure out what's going to be what, right? Or if you have a really sharp deadline, if you speed is everything to your iteration speed and production speed. And then you have the pragmatic approach, which is the one that I advocate. So when it comes to having the pragmatic approach, the mindset that I try to go for is that I try to figure out, I only write unit tests for things that I know is important, that is something that that is extremely important to test. A great example is the other day I was just writing a search. It's just a list of events for an administrative panel at my company. And so there's an interface of like just row after row of row of user and user associated information and their orders and like all of that good stuff. It's just a dumb list where you can with links that can link you to other pages. But the requirement was that you should be able to filter this list so that you can see different ranges of times, users with certain names and so forth. You should be able to filter on many different attributes, right? Or columns, if you will. So I implemented the whole thing. I wrote all of it like just from scratch, and it looked exactly the way it should. And then I just had the logic that, all right, just show everything in the list that's coming from the server. But I wrote unit tests for the filtering logic. Now, why would I write unit tests for the filtering logic and not the rendering and like the tables and like all of that stuff that is a lot of people in Jest and use Jest and Enzyme when they're working with React to verify that the markup looks the way that it does. And here's why I argue that the value for me, as this is an administrative panel, it's not something that is user-facing. If it breaks, it's not a big deal. The only thing within this feature that is truly complicated is the filtering logic, because if a user if one of our admins wants to filter between two date ranges and a name, but sometimes they might just have a name and then they don't have the dates, and a third time they have another parameter. Like there's all these different variations that can get very tricky when you want to accurately filter a list based on these different values, right? That's complicated logic. That's logic that is very likely to be incorrect, or rather it's very likely that I will get that logic incorrect. So by using test-driven development, I can actually make sure that this complicated part of this feature is actually working correctly, because all the other stuff is fairly trivial in comparison. That's the sort of mindset I think that you should apply when it comes to test-driven development. You should always write tests for code that you're very sure that this is important software. Like this piece of the code is very important. It has to work, or you are very sure that it's very likely that this is going to be changed or somebody's going to involuntarily break it. Because that's why 100% test coverage is going to give you all that value, like this value. It's very costly to have 100% coverage, but the benefit is, as I said, if you're changing something over here, then something over here might break without you even noticing that it's happening. Usually that's how regression bugs come into play, and that's what unit tests and test-driven development is going to help you with. Preventing regression tests and making sure that the code that you write is actually working the way that you expect it to work. So that's the goal, guys. That's the benefit. And this one rule is for the pragmatists out there. This is my mindset, how I work. So I create, usually when I write unit tests, I create one or two or a few tests depending on what I think is like the sane cases, sane tests, like the normal use cases. And then if I ever have a bug that is associated with the logic that I just wrote, then I go and I write a new test that covers that case, so that I can create a test that asserts that, all right, this error is here, and when I fix the test, I know that this logic is now working. I know that I fixed the bug, if you will, and that bug is never going to come back. So think of it as an exhaustive thing, where you might have a bug, and then you fix the bug and you write a unit test, and then you never have that specific bug again. And then the next bug comes, and you do the same thing, and then you do the same thing over and over and over until you never have any more bugs associated with this complicated feature. But apart from that, I don't write unit tests for, I don't write unit tests for things that I need to produce very quickly, or things that are fairly simple, or stuff of that nature. That's at least how I think about it, and you will find that unit tests are, as I said, it's a very diverse ecosystem out there in the work industry. My rule of thumb, generally what I see is that people do not, it's very, very rare to have 100% unit test coverage. As I said, it's really extreme cases where this is very important. And every single company wants you to be aware of it, because every single company wants you to, most often they want you to be a pragmatist, as I've been telling you. And then there are the companies who don't care about it at all. There are different flavors, so you're gonna just have to kind of roll with the punches on this one, depending on the company that you join. I hope you have a great day.